So we are going to look into the last segment of our determinants, still on solving of the simultaneous equations. The only difference now is that we are dealing or we are working with three unknowns. All right, with three unknowns. So the question is, how are we going to solve when dealing with three unknowns? The procedure is still the same as before. It's procedure, same as what we had for two unknowns, only that the format has to change because we now have what? Three unknowns that we have. So the standard form definitely is going to change. We are going to have our simultaneous equations represented in the form a1x plus b1y plus c1z, which is equal to d1. So a1, b1, c1. These are coefficient of x, of y, and of z. So x, y, and z, these are the unknowns to be what? Determined. You must determine x, you must determine y, you must determine z, and d1 as your constant. So same, the second equation, remember three unknowns, 1, 2, 3 unknowns. We must have three equations as well. Just like two unknowns, two equations. Three unknowns, three equations. So the second equation, a2x plus b2y plus c2z is equal to d2. That's our second and third equation, a3x plus b3y plus c3z must be equal to d3. So this is the format, the standard form that you must have. And with that form, the Cramer's rule states that x is equal to delta x over delta naught, just like before. What is for x? Over the coefficients. And y will be equal to delta y over delta naught. And z will be equal to delta z over delta naught. So simply as before, I must determine determinant for x, for y, for z, and those for the coefficients. So this is exactly the format and the procedure to solve simultaneous equations for three unknowns. So we can see that it is just like before. It is just like what we had for two unknowns. We have to rearrange the equations into the standard form. All right, remember our standard form. Constants will be on the right-hand side, x, y, and z on the left-hand side in that order. Then determine the determinant of the coefficients, delta naught. You determine that one for x, you determine that for y, and you determine that for what? For z. Then apply your Cramer's rule as before. You can see that it is just a repetition. So the question is, how are we going to find these delta x, delta naught, delta y? As before, in order for you to determine or to have delta x, it is x which is affected. So this time, as we can see, we have got 1, 2, 3 rows that we must obtain from that. But remembering that what is for x, you cover up, you close it, then replace with constants, as what we had when dealing with 2. Only that this time they are now 3. So you close the part of x, replace with the constants. So these are the constants, d1, d2, d3. You replace them in place of what? In place of x. Just like that. This part as it is. It is taken in place of x. You are dealing with X. So we're going to have D1, D2, D3. Y and Z will be as they are. B1, B2, B3, the coefficients. All right? The part of Z as it is, C1, C2, C3 as it is. Just like that. Just ignore X. Put constants there. So same as of Y. Ignore, it is Y that is affected. Remember X, so the part of Y is affected. So X is written as it is. As it is. It is the part of Y which is affected this time. It is part of Y here. So you take that of X as it is, those coefficients as they are. A1, A2, A3. All right. So you're going to have A1, A2, A3. But Y is affected. So you replace it with constants. What is affected is replaced with constants. So you're going to have D1, D2, D3. Z is not affected. As it is, the coefficient C1 up to C3. Just like that. So you see, guys, just a repetition. We already dealt with this, only that it was for two unknowns. But you can see it's a repetition. So same as of that of Z. It is Z that is affected. So you close that part of Z, replace it with constants. Just like that. So meaning to say X and Y, they are going to remain as they are. The part of X is going to remain as it is, Y, but Z is now affected. So X, what are the coefficients? You replace them as they are. A1, A2 up to A3. Y is not affected. Take it as it is in that order. B1, B2, B3. Z is the one that is affected. X, Y, Z. So Z is now to be replaced with constants. D1, D2, D3. So this is the case of our determinants. The first part, it was X which was affected. The second part, it was Y which was affected. What is affected is replaced with the constants. The last part, it is what? Z which was affected. You replace it with constants. Then delta naught, which is of the coefficients, is not affected at all. The constants are not to be considered, just like when we had those two unknowns. For the constants, it is not affected. So you're just going to have your delta naught, the constants, as it is on the left-hand side, X, Y, and Z. They are not affected. So you're going to take your X as it is, those coefficients, A1, A2, A3. Y is not affected, B1, B2, B3. Z is not affected, C1, C2, C3. So this is the format. And you must determine these determinants. So we are back to the finding of determinants, where we dealt with this in one of the classes when we're determining or evaluating determinant on the third order. Remember, I told you guys you can do this by using the cofactor expansion method. That is, you can expand any row or any column using cofactors. So finding of the determinant, you already know how to do that. For 3 by 3 matrix, which is the third order determinants, we had this here, if you still remember, when we dealt with this example, where we managed to expand using the first row, and we proved by expanding using the first column. So determinant of the third order, you already know how to determine it. So it's a continuation. So do not leave any part unattempted. Each and every part, you must understand it, because you can see it's a continuation. We have to go back to those determinants now. Once you can determine your determinant, guys, you are done, because these are the ones that we need here. So we're going to need that of x, y, z, and of the coefficients, all of them. 4 of them. Depending with the question, are you to solve for x only? Are you to solve for y only, z only? Or you are being asked to solve for x, y, and z? If you are being asked to solve for x, y, and z, it means we must determine all. But let's say they said solve for x. There's no need for you to find that of y and that of z, because you need x. So you're just going to focus on delta x and delta naught. Those two, they are enough. You can find x from there. If you want y, you do the same thing, delta y over delta naught. Not to say you find that one for x, also for z. No. Answer the question in exam. Do not say I was taught this way, so I answer that. No, you answer the question. What is the question? All right. So I'm not going to waste your time. I'm just going to have one example that I'm going to use. And from that, I want you guys to work out as many questions as you can. Like I say, this is the last part or the last segment of our determinants. Solving what? Simultaneous equations, where we are using the Cramer's rule and having 3 unknowns. So from there, it is you guys working out more questions. All right. So let me just put one example. Let's say we are being asked, in our case, we are going to solve for everything. All right. We are going to solve for x, y, and z. All right. Using the Cramer's rule. Using the Cramer's rule. So given these equations, 3 is equal to minus 3x plus 2y. All right, this is minus 3z. Sorry for that. Sorry for that. Minus 3z plus 2y. All right. Plus x. Another one. 2x minus y minus 11 is then minus z, sorry. Minus z is equal to 0. 2y, another one, plus z plus 5 is equal to minus 3x, right? That's our third equation. So I'm going to use this one as an example. Then guys, do as many questions as you can, all right? Just revise basics, question papers. That is the best way that you can understand the topic, all right? So as we are to solve for x, y, and z, meaning to say we're going to need every determinant of each and every part. But remember what we said, we must rearrange the equations into the standard form, and we do understand that the standard form, x, y, and z on the left-hand side, the constants on the right-hand side. So meaning to say, all right, let's check our first equation. We need to rearrange first. So our first equation, we can see that x, y, and z, They are already on one side of the equation. So we just need to take them to the left-hand side and 3 to the what? To the right. It's just swapping these two. There is no change of sign or what. Just take as it is, starting with x. So the order x, y, z. So we're going to start with x, followed by what? By this part of y, which is 2y, followed by the part of z, which is minus 3z. What is on the right hand side is equal to the left hand side. So you're just going to equate it to what? To 3. There is no need of you swapping. You say this to the other side is a negative. Guys, already all the terms of x, y, and z, they are on one side of the equation. The constant on the other side of the equation. Just equate the two, you're done. All right. The second equation, we can see that x, y, and z, yes, they're on the left-hand side. We've got x here, 2x minus y minus z. All right. But the minus 11 is to be taken to the other side because the constant, this one, it must be taken to the right-hand side of the equation. So if we transpose it to the other side of the equation, it will change the sign and become what? A positive. So this one, we have to take it to the other side so that it will be a positive. Just like that. The third equation, we can see that, all right, the terms are just randomly given here. So let's take this x to the left-hand side as we've got other terms already on the left-hand side. So let's take this. Minus 3x is going to change the sign the moment it crosses the equal sign. So that will be positive 3x. Already y and z are on the left-hand side, so no change of sign, just rewriting as they are, 2y plus z. That must be equal to the constant 5 to the other side is going to change to a negative. We have taken it to the right-hand side, so it has to change the sign. So this is what you were going to have finally after rearranging. You are saying these are the equations that I'm dealing with. And from these equations, I must determine x, y, and z. As we saw that x, y, and z must be taken from the Cramer's rule formula, where we must have determinants corresponding x, y, z. All right? Just like that. So let's start with that one of x. It's up to you. You can start with the constants, or it's up to you guys. So x, it simply means we are covering up x replaced with constants. Remember what you are finding x. You cover up, you replace it with what? The constants. And these are the constants that we have on the right-hand side. So in place of x, we're going to substitute y. It's going to remain as it is, z as it is. But x is what? X is affected. X is affected here. So we're going to substitute the constants as they are. 3, 11 minus 5 as it is. All right. Y is not affected. So we take the coefficients 2, positive 2, positive 2. Here, this is negative 1. All right. So we've got negative 1, positive 2. Z minus 3, the coefficient there, minus 1, and this is just z, so it's 1 there. So it's positive what? Positive 1. So this is your delta x. Determine the determinant. You move on to y, z constants, or your coefficients. Just like that. All right, just for the sake of time, let me just do this separately. X, remember your determinant, guys, when it is of the third order, we go back here where we had to expand any row or any column using this concept of our cofactor expansion. You still remember? So I'm going to use, or I'm going to just expand using the first row. So as for me, I'm just going to use the first row, remember the signs in the first row, it's plus, minus, plus, and so on and so on. So these are the signs affecting the first row. All right, so meaning to say our delta x is going to be equal to 3 with its sign a positive. So it's going to be positive sign first, then the element, which is 3. So remember, guys, sign, element. Then you determine the determinant by closing the row and column where that element is. Where element 3 is, you close the row and the column. Remember our previous calculations, guys. You close row and column where that 3 is. So you'll be left with this part. That is the determinant you are going to determine. So thus we are left with what? Minus 1, 2, minus 1, 1. All right, you're done. So you're going to move on to the next, which is what? Which is the part of 2. This 2 in this row, you're using the first row. So 3 is done. So you move on to 2. The sign first affecting 2 is what? A negative sign, negative. So it's going to be negative 2. Then you determine the determinant by closing the row and column where that 2 is. We close the row and column where that 2 is. This is row and what? Column where 2 is, this 2. So you are left with what? What you are left with, determine its determinant. You are left with 11 minus 1 minus 5, 1. All right, so this is just a repetition of what we have done before. Let me quickly move on to the other one. Minus 3, the sign first is what? Positive. So there's the sign, but the number is what? Our term, our element is negative 3. All right. Then we determine the determinant by closing the row and column where that element, negative 3, is. We close the row and the column where it is found, where minus 3 is found. What you're left with is what? You're left with 11 minus 1 minus 5, 2, just like that. So this is your determinant. By evaluating this, you are to determine determinant of x. All right, so that's plus 3. Determine our determinant. All right, so this is major diagonal. Minus 1 times 1 minus the minor diagonal minus 1 and what? Minus 1 and 2. All right, like this. So you've got determinant there. Minus 2. We find the determinant again for that. This is our major diagonal, 11 and 1. All right, minus, this is what? Negative 1 and negative 5. Guys, am I going to do this up to the end? Am I going to do this up to the end? Or you now understand, guys? Plus and minus, that's a minus. But as of exam, you must do this. All right, here I'm just saying, guys, I've been recording a lot to cover up this topic. And I had to, because the request was too much and there was no way. I had to work out these introductions up to the end. So you must also understand me, guys. So I'm just gonna try. All right, let's see. Time is gonna tell. Time is gonna tell. So because of time, I want you to just evaluate everything here. Just use your calculator. So it's going to be 3 times. After evaluating this, you're going to get a 1. 3 times 1 minus 2. You evaluate everything in this bracket. You're going to obtain positive 6. Minus 3. You evaluate everything here. You're going to obtain 17. All right. Then use your calculator to simplify everything that was going to give us a negative what? Negative 60. So this is it. You have your determinant. So if you had expanded by any row, any column of your choice, you're going to obtain the same answer. Negative what? Negative 60. You're going to obtain same value for that determinant. So you choose, it's in your hands. Which one are you going to use? Any row, any column. So that was for X. But we saw that, guys, we must do this for Y, for Z, because we are to determine X, Y, and Z, all right? So, like I said, okay, let's see. Let's see, guys. Let's see. I'm the one who started this, guys. Let me just finish it. There is no way. There is no way. All right. So this time, delta X, we are done. So let us move on to delta Y, because we have to find everything here. So the part of Y is the one that is affected this time. You cover it up, then replace with what? Then replace with constants. Y is affected. So meaning to say, X, Y, and Z, they're just going to remain as, X and Z will remain as they are. But Y is affected. We have to replace it with what? Constants. Do not forget the concept. So this is it, delta Y. X is just going to remain as it is. The coefficients 1, 2, 3 as they are. All right. Y is now affected. Substitute with constants. 3, 11, minus 5, just like that. Z is not affected. We're just going to take it as it is. Minus 3, minus 1, and positive 1 at the end. So this is your delta Y. You find your determinant just like before, all right, expanding any row or any column of your choice. So just for the sake of understanding, I'm just going to use the first row. Remember, these are the signs of the first row. So I'm just going to expand from the first row. All right. So meaning to say my delta Y was going to be what? Using the first row, we have got 1 affected by what? A positive sign first. So that's plus 1. Then you find the determinant by closing row and column where that 1 is. So close this, close this. So you're going to remain with what? 11, negative 1, negative 5, 1. All right, you move on to the next one, which is 3. So 3 is here. So we're going to close the row and column where that 3 is. All right. So the sign is what? Negative there. So negative 3. All right. Then find the determinant by closing the row and column where 3 is. This is the column affected. So you are left with what? What you're left with is going to be your determinant that is remaining 2, minus 1, 3, and 1. All right, just like that. You move on to negative 3. The sign first affecting there is what? A positive. But the number is negative 3. Then you determine the determinant for that. Just like that. We are focusing on negative 3. So we close the row where it is found and also the column where that negative 3 is found. So you're going to be left with what? 2, 11, 3, and what? Minus 5. This will be your determinant. If you expand everything, you are going to obtain the determinant with respect to Y, just like before. All right, so let me quickly write this. Right. Let me quickly have this. This is 1. And our determinant, major diagonal, versus what? The minor diagonal. So the major diagonal, 11 and what? 11 and 1, minus the minor diagonal, minus 1 and minus 5. So this is it, minus 3, determinant here, 2 versus 1 in the major, minus 1 and 3 in the minor. So that was going to be 2 times 1 minus 1 times 3. And plus and minus is going to give us a negative. So it's going to be -3. We have to determine the determinant. So also, guys, where I make an error or something, just try to correct it, because you can see that there are a lot of values, so you can just make a mistake, but the idea is the one that I'm showing you here. Just follow up the idea. All right, just follow up the idea, do many questions from that. So major diagonal 2, -5 minus what? 11 times 3. So that was it. You had to simplify, evaluate this to have your determinant each and every part. So it's going to be simplify the bracket here. That was going to give us a 6 minus 3. Simplify this, you're going to obtain -5, +5 actually. It's going to be positive. Negative is going to be positive. All right, minus 3. Evaluate this this part here. You're going to obtain -43. All right, so simplifying this, our delta y was going to be 120. How was it? All right, it's because of this negative. All right, negative is going to be positive there. So that's our delta y, 120. All right, just verify also using your calculator. Just verify each and every step, guys. Do not just take values, but as long you know the idea, the rest is just simplification. So that was it for y. Let us move on to z, and we have for the coefficients. So delta z, this time it is z which is what? Which is affected. So we are going to close it and replace with what? With constants. So meaning to say x and y, they are not affected. It is only z. So x, as it is 1, 2, 3, the coefficients. Y is what? 2, -1, +2. But z has to be replaced with the constants. 3, 11, -5. Then you determine your determinant. So I'm going to expand using the first row again. This is our first row. And remember the signs plus, minus, and plus. So, guys, this is just now a repetition. A repetition. If you're in exam, then it is asking you to calculate for X, Y, and Z. These are the stages that you must actually follow, but you'll be seeing is just a repetition. So uh, do not worry about that, guys, because you are just repeating one thing. All right, maybe it can be a 10-mark question. Still, yeah, it is worth it. It is worth it because it's just repeating. All right, so sign first for 1, which is positive. Then 1 determinant. Close the row and column where that element 1 is. Close the row and column. So this is the column where that 1 is. You'll be left with what? This part. This is your determinant, -1, 11, 2, -5. Let us move on to 2. 2 is being affected by the sign negative. 2 corresponds with a negative. So it's going to be negative what? -2. Determinant of when we close the row and column where that 2 is. So we close that. We'll be left with what? 2, 11, 3 minus 5. Just like that. Then the last one is 3. And the sign is what? A positive. So positive what? 3. Determinant with respect to that, when you close the row and column where that 3 is, you'll be left with this part, 2, -1, 3, 2, in that order. So this is it. Let us determine our determinant. we are having our delta Z from there, determinant of what? Of Z. So that's direct positive 1 into what? Negative 1 and what? And negative 5, 11, and 2, just like that. So it's going to be negative 1 times negative 5 minus 11 times 2, just like this. Minus 2, determine the determinant corresponding to that 2 versus negative 5 as our major diagonal 3 and 11. So that's 2 times negative 5 minus 11 times what? 11 times 3. All right, then we move on to this one, positive 3. All right, we do the same, the major diagonal 2 versus 2. And we have negative 1 versus 3. Just like that. 2 times 2 minus negative 1 times 3. So just verify, guys, your values and so on and so on. Just verify your values. Use your calculators also to verify if you are on the same page. So this is 1. Determine the determinant or the value of this one in the bracket. That was gonna give us negative 17. Okay. And minus 2, determine this. That was gonna give us negative 43 plus 3, determine this is gonna give us 7. So if you evaluate everything on your calculator, that was gonna give you a positive 90. So that's determinant. That is with respect to what? To Z. Positive what? Positive 90. And the last one is of the coefficients now, our delta naught. Delta naught. Just like that. So you see, it's an interesting question because it is full of repetitions. Maybe it can be just tiresome to say, oh, I'm working the same thing now and again, now and again. But guys, if it is exam, then you just have to follow that. Remember, exam also, they are testing you, your patience also. Fault finding. Engineering is about fault finding. Can you be able, if there is a mistake, can you be able to trace back with these 3 unknowns like that? So yeah, they'll be testing you all those things. So let's just have our constants, delta naught. Remember, this time, nothing is affected. X is not affected, Y is not affected, Z is not affected. So you're just going to take those coefficients as they are. 1, 2, 3 for X. Y, 2, minus 1, 2. Z, minus 3, minus 1, 1 as it is. Then find the determinant. I'm going to use the first row again, plus, minus, plus, just like before, so that we do not have challenges. So I'm just going to expand using the first row. All right, so our delta naught was just going to be equal to where 1 is, we must consider that. Let me just already cover the row because this is just going to remain like that throughout. All right, so where our 1 is, it corresponds with a positive, the sign first, positive 1. Then we determine the determinant when we close the row and column where that 1 is. So if we close this column, that was going to give us a 2 by 2 that is remaining here, minus 1, minus 1, 2, 1. All right, then we move on to 2, element 2. Element 2 is affected by the sign, a negative here. So that's negative 2. Negative, then the element. Determine the determinant when you close the row and column where that element is. So you're going to close also this column where 2 is already, the row is closed. So you're going to remain where this. Just like that. All right. So that was going to give us 2 minus 1, 3, 1. All right. Negative 3, but the sign first. The sign is positive. So that's a positive. But what we have there is a negative 3. Then we're going to determine the determinant when we close the row and column where that negative 3 is found. We must close the row and the column. So you're going to remain with this. And that's our simplification, guys. So you can see it's just repetition. So determine that delta naught. 1, that's a positive. Then we're going to need determinant, major diagonal. All right, or major diagonal versus the minor diagonal. So that was going to be negative 1 times 1 minus negative 1 times 2. You are done. Move on to the next one, negative 2. Determinant, which corresponds here 2 versus 1 minus 1 versus 3. So that's it. 2 times 1 minus, this is negative 1 times 3. So this is it. Then we move on to the last part. Positive, negative is going to give us what? A negative. So that's negative 3. Then determinant is going to be what? All right, 2 versus 2 minus 1 versus 3. So it's going to be 2 times 2 minus negative 1 times 3. Negative 1 times 3. All right, something like this. So you're going to need to evaluate now using the calculator this whole part. So it was going to be 1 times 1 minus 2. Simplify this. It's going to be positive 5 minus 3 times this whole part, which is going to give us a 7. So our delta naught was going to give us negative 30 at the end. All right, just like that. So a good repetition that you're going to be having under exam. If let's say you are to calculate X, Y, and Z. But like I said, some questions will be just solve for X or solve for Y, or it is just for Z. So if it was for X, you were just going to need X and delta naught. If it was for Y, you're going to need delta Y and delta naught. If it was for Z, delta Z and delta naught, there is no need for you to calculate everything. No. But in our case, remember, we must solve for each X, Y, and Z. Using the Cramer's rule, it states that X is equal to what? Delta X over delta naught. Remember our formulas as before. Just like that. So meaning to say our delta X, our X, is going to be delta X negative 60 over our delta naught negative 30. And that was going to give us a positive 2. So we've got the exact value of X. X is equal to 2. So it is the same for Y, delta Y over delta naught. So Y, our delta Y is what? Positive 120 over delta naught negative 30. Simplify this, you're going to get a negative 4. Then Z, the same thing, delta Z over delta naught. So Z 90 and our delta naught negative 30. So that's our Z was going to give us what? Negative 3. So that is it. We have got the values of X and Y and Z. Using the Cramer's rule, we can solve for 3 unknown values, as we can see. We can solve for 3 unknown values, just like what we had with two unknown values. So all you need, guys, is the procedure, arrangements of their equations into the standard form, finding of those determinants each, the coefficients, the determinant of x, the determinant of y, the determinant of z. Then you can simply apply the Cramer's rule, just like that. So more questions as we proceed working with question papers. But if you check, I've done full papers. You can check those full papers where we have determinants, then work out those questions. That is the best way of what? Of revision. Do revise as many questions as you can. So that is it, guys. Till we meet again.